ইঞ্জিনিয়ারিং স্টুডেন্টস। আমাদের স্টপ অ্যান্ড ওয়েটটা হয়ে গেছে, স্টপ অ্যান্ড ওয়েট প্রোটোকল। The stop and wait for noiseless, stop and wait automatic repeat request. এটা হচ্ছে স্টপ অ্যান্ড ওয়েট অটোমেটিক রিপিট রিকোয়েস্ট। এটা তো আমরা আগের দিন করলাম, সেন্ডার সাইড অ্যান্ড রিসিভার সাইড প্রোটোকল। এটা বুঝতে পেরেছো তো? কারোর কোনো অসুবিধা থাকলে বলো। ঠিক আছে তো? হ্যালো, এই শোনা যাচ্ছে? স্ক্রিন দেখা যাচ্ছে, শোনা যাচ্ছে, দুটোই হচ্ছে তো?
হ্যাঁ ম্যাম।
ঠিক আছে। তো এটা তো আমরা আগের দিন ডিসকাস করলাম। তো এখানে স্টপ অ্যান্ড ওয়েট ARQ, দ্যাট মিনস স্টপ অ্যান্ড ওয়েট অটোমেটিক রিপিট রিকোয়েস্ট। তো যখনই কোনো ডেটা করাপশন হবে, এখানে সিকোয়েন্স নাম্বারটা রেখে দেওয়া থাকে। যখন সেন্ডার সেন্ড করছে কোনো ফ্রেম, তো সেই ফ্রেমের করসপন্ডিং সিকোয়েন্স নাম্বারটা সেন্ডার স্টোর করে রাখছে। ঠিক আছে, তারপরে হচ্ছে সেই করসপন্ডিং সেই ফ্রেমটা যদি তার অ্যাকনোলেজমেন্ট না পায়, সেন্ডার যদি না রিসিভ করে রিসিভারের থেকে, তখন কি করবে, ওই যে সিকোয়েন্স নাম্বার স্টোর করেছিল সেই জন্য ওই 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 ফ্রেমটার একটা কপি, তার মানে একটা কপি রেখে দিচ্ছে, সেই কপি ফ্রেমটা আবার হচ্ছে পাঠিয়ে দিচ্ছে। যদি টাইমার আউট হয়ে যাচ্ছে এবং অ্যাকনোলেজমেন্ট রিসিভ না করছে। তো আর একটা কেস হয়, ধরো ডেটাটা রিসিভ হয়েছে কিন্তু অ্যাকনোলেজমেন্টটা লস্ট হয়েছে। এই কেসটা অ্যাকনোলেজমেন্টটা লস্ট হয়েছে। সো অ্যাকনোলেজমেন্ট যদি লস্ট হয়, তখন কি করবে, তখন এখানে যে রিসিভার তো ধরো 0th ফ্রেমটা অ্যাকসেপ্ট হয়ে গেলে রিসিভার অ্যাকসেপ্ট করতে চাইবে 1 নম্বর ফ্রেমটা। কিন্তু যদি অ্যাকনোলেজমেন্ট না পায় সেন্ডার, দেন সেন্ডার কি করবে, আগের ডেটাটাই আবার সেন্ড করবে। তো আগের ডেটাটা যদি আবার সেন্ড করে, তখন সেই ক্ষেত্রে কি হবে, রিসিভার দেখবে যে ওটার এক্সপেক্টেড যে ফ্রেম সেটা নয়, তখন কি করবে, ওটাকে ডিলিট করে, মানে ওটা আগের মানে এটাকে ডিসকার্ড করে দেবে, এই ফ্রেমটাকে ডিসকার্ড করবে এবং অ্যাকনোলেজমেন্টটা আবার পাঠাবে। তো দেন অ্যাকনোলেজমেন্ট তখন রিসিভ হয়ে যাবে। ঠিক আছে, তো এইভাবে জিনিসটা হলো। এগুলো কিছু এক্সাম্পলস আছে, তো প্রবাবলি প্রোটোকলে আমরা আসবো। আচ্ছা, so this is the flow diagram of stop and wait ARQ. Okay, automatic repeat request. So automatic repeat request is, that means the request is automatically done from the receiver, that means from the receiver end, and automatically that value has to be, the frame has to be sent to the receiver. Okay, and if there is any data corruption, then data must be resent again, because there is a mechanism to store the sequence number of the sent data, and the copy of that frame should be stored in some buffer, and if there is any loss of the frame, then data should be resent. Okay, so this is the flow diagram. So now take an example. Assume that in a stop and wait ARQ system, the bandwidth of the line is 1 Mbps. Okay, that is the channel capacity, and 1 bit takes 20 milliseconds to make a round trip. That means the whole thing, that means 1 bit received by the receiver, and then it is acknowledged it is received by the sender. So whole things should be done in 20 milliseconds. What is the bandwidth delay product? That is the first question. And if the system data frames are 1000 bits in length, what is the utilization percentage of the link? Okay, so here bandwidth delay product, so we have 1 bit 1 Mbps, the bandwidth is 1 Mbps, so make it bit per second. so it should be 1 into 10 to the power 6 into 20 milliseconds. So make it a second. So how much time it will take? It will take 20, how many bits? The bandwidth delay product is what? That is 2000 bits. Okay, 2000 bits they can send. If the system data frames are 1000 bits in length, what is the utilization percentage? Utilization percentage টা দিব না এখানে। তো এই যে এইটা করতে হবে। So if what is the utilization percentage of the link, then the bandwidth delay product is 20,000 bits. The system can send up to 15 frames or 15,000 bits during a round trip. That is given that this is given that can send up to 15 frames before stopping and worrying about the acknowledgement. So 15 frames they can send. So that means 15,000 bits. Okay, one frame means 1,000 bits. So 15 frames, 15,000 bits during a round trip. This means utilization is 15,000 divided by 20,000. Okay, so 20,000 bits they are passing. The channel bandwidth, that bandwidth delay product is 20,000 bits, and 15 frames they want to send. So utilizations should be 15,000 divided by 20,000, so up to 75%. Okay, so if there are damaged frames, the utilization percentage is much less because frames have to be resent. Again, you have to resend the frame. Okay, so this is a small example. Now we have to go for another protocol, that is Go Back N protocol. And here the sequence numbers are modulo 2 to the power m, where m is the size of the sequence number field in bits. That is the sequence number field. M is the size of the sequence number field. So Go Back N protocol, what does it mean? So at first see this send window for Go Back N protocol. So here we have some frames, and if the value of m, if m is suppose if it is 7, okay, if it is 7, then 0 to that means 2 to the power 7 minus 1. Numbers are modulo 2 to the power m, where m is the size of the sequence number. M is the size of the sequence number. তো এখানে দেখো ফার্স্টে frames already acknowledged, this 13, 14 and 15. So we have 0 to 15, these numbers, these frames we need to pass. That means 16 frames we have. That means bit size is what? That is 4. M is it to be 4. Okay. Sequence number size is 4. So that is this is not 7. This is 4. Okay. So 2 to the power 4 minus 1. So that means you have a 15 frames. So here the 13, 14 and 15, these frames are already acknowledged, and 0, 1, 2, 3, 4, 5, 6. These frames are sent but not acknowledged. These frames are sent, and frames that can be sent, that is frames that can be sent, that is but not received from upper layer, this can be sent. So here is the SF, this is the first frame, and SN is the next frame to send. Okay, so SF, two things we should mention here, that is SF and SN. SF is the first frame, that is first outstanding frame what we need to send, and SN is the send window, next frame to send. This is next frame to send. Okay, so SF and SN, we will use this sequence number. So these are the things, and if m equal to 3, that means what? 2 to the power 8 minus 1, that is 7. Window size is 7. So here we can send the 7 bits, and we have 15 frames. 15 frames we have, but we can, and after 15 frames we can again repeat 0, 1, 2, 3, 4, 5, 6 up to 15. Okay, but window is here, I think it is taking m equal to, okay, is not given. So m equal to 3, I think. Then the size is 0 to 6. That means 7 frames. Same window size is this. Okay, that is the send window. This is the send window, and this is the send window next frame to send. So 2 categories are there, you have to know that. And first category is the first outsending frame which is already sent, but the acknowledgement is not received, and another is the next frame need to send, okay, and it is not received by the upper layer. So this window concept is very important here. So to send window is an abstract concept. This is an abstract concept defining an imaginary box of size to the power m minus 1 with 3 variables SF, Sn and S size. Okay, we have SF, we have Sn and S size. The send window can slide one or more slots when a valid acknowledgement arrives. Okay, send window can slide one or more slot. When the acknowledgement arrives, then it can slide the next slot. And receiver window, this is for receiver window. Receiver window is a single bit, there is a single frame it can receive at a time, and it can receive the single frame at a time, and again after receiving the frame it can slide to the next frame. Okay, so this is the received window for Go Back N Arq. So this is the sender window, that is we can send 0, 1, 2, 3, 4, 5, 6, okay, but receiver can only can expect only single frame at the receiver end, that is Rn. Okay, so the receive window is an abstract concept defining an imaginary box of size 1 with one single variable Rn. The window slides when a correct frame has arrived. Sliding occurs one slot at a time. So this is a design of Go Back N Arq. Okay, here we have first out. See, this is the first outstanding, the red mark. This is the first outstanding frames, and this is the next to send. So here the sender is getting the data from network layer, that is getting the data from network layer, and from network data link layer receive the data and it sends to the physical layer, and after that through the transmission medium it can send the data to the receiver, and receiver will receive the data. Receiver will receive the frame and it will deliver the data to the the upper layer. So here is the acknowledgement number. They can pass the acknowledgement number. So acknowledgement frame they are passing. So from the receiver, the sender can get, even here also they can get the acknowledgement. So this is the there is a problem of in case of Go Back N Arq. Okay, in Go Back N Arq we have a window size. There is a window size problem. See, the window size is less than 2 to the power m. Okay, window size is less than 2 to the power m, and here is less than if the window size is equal to 2 to the power m, then what will be the problem? Here the size of the window must be less than 2 to the power m. Here the window size must be less than 2 to the power m. Okay, so if suppose if we have m equal to 2, if we have m is equal to 2, then the window size must be 2 to the power m minus 1. That means 4 minus 1 should be 3. Okay, so if it is that means we can have only 3. The window size must be 3. See, 0, 1 and 2. This is the window size. Okay, so here obviously in case of back in ARQ, the window size must be less than n. Okay, it must be less than n. So why it is required? So suppose, see, if we have less than n, then at first we are sending the frame 0. Okay, and the acknowledgement, this is the acknowledgement, and acknowledgement is lost. Okay, so Rn is 0, Rn is received, frame 0 is received by receiver, but the acknowledgement is lost. And after that, so Rn, this windows will be slide to the next frame. So Rn now indicating the first one, it expecting number 1, this frame, but again this one, this the timer is on. Okay, so now sender send again the next frame, that is frame 1. Then the acknowledgement also lost here, and Rn is again wants to receive frame 2. So frame 2 is passing here, and then frame 2 is passing, and this is also received because the receiver is expecting the frame. So whatever the frame or receiver is expecting, if that frame is received by the receiver, then only the receiver can accept that frame. Okay, but here you can see the acknowledgement is lost. So when the timer is time out, when this time is out, okay, then what will happen? If timer is time out, then frame 0, then sender actually feel that no frames is received by the receiver because no acknowledgement is received by the sender. So sender will, because window size is 0, 1, 2, window size is 3 frames are there. So next time it will send the frame 0 again, it will send frame 0 again. Okay, because window size is 0, 1, 2, less than 2 to the power m. So it can send the frame 0 again. So when frame 0 is sending to the receiver, then receiver see that this is frame 0, this is not frame 3. So it will be correctly discarded. It will be correctly discarded because the receiver is expecting frame 3, but frame 0 is passing. So it will be discarded. That means no duplicate frame is accepted by the receiver. But if the window size is 2 to the power m, see, the window size is 0, 1, 2, 3, 2 to the power m. Okay, so 2 to the power 2 equal to 4, that is frame size is, window size is 4. So 0, 1, 2, 3, in that case what will happen? The same thing, suppose 0, 1, 2, all those acknowledgements are it is not, is corrupted, and frame 3 is also sends, and this is corrupted. Okay, so all the acknowledgements are all the acknowledgements are corrupted. So and now receiver, see, receiver is received all these values 0, 1, 2, 3, and it is expecting frame 0. But here when this timer is out and sender is they are seeing that no acknowledgement is received, then sender is sending what? This frame 0, what the sender is sending, that is this frame 0, this is the duplicates of this frame. Okay, this frame, this is the duplicates of this frame. But frame 0 is expecting, receiver is expecting the next slot, that is next frames to expect, to receive. Okay, that means the next slot, that is 0, 1, 2, 3, next this zeros should be there. So this is not, the receiver will not expect the duplicate frames, but erroneously when the frame 0 is passing to the receiver, receiver erroneously received that frame. Okay, so accept the frame is accepted by the receiver. So this is the error. So if window size is 2 to the power m, then this type of errors can occur. That's why the window size must be less than 2 to the power m. Okay, if it is equal to 2 to the power n, then duplicate frames will be accepted. So in Go Back N Arq, the size of the same window must be less than 2 to the power n, and the size of the window is always 1. Okay, remember it. So window size of sender must be less than 2 to the power n, and size of the receiver window always 1.